Classwork 6.10. Association is not causation. Just because two quantities are correlated does not necessarily mean that one is directly causing the other to change. Correlation does not imply causation, just like cloudy weather does not imply rainfall, even though the other is true. If two quantities are correlated, then there might well be a genuine cause and effect relationship, such as rainfall levels and umbrella sales. But maybe other variables are driving both. Or perhaps it's just a coincidence. As a consumer of statistical information, you need to be aware of the difference between association and causation. Today's investigations will explore that difference. All right, today's a very, very different day than what we've been doing. So today's going to be all pretty much interpretation and trying to understand the problem. There's not really any math that we're doing. There's not really anything we have to put into the calculator. You guys just have to interpret the problem, read the problem, and understand if the correlation is implying causation or if there's something else happening there. So, question number 1. The mayor of Smallville finds the following graph in the town's financial report. Describe the association, if any, in the scatter plot. So, we've got our association here. Let's take a look at what this graph is showing. Let me move it up a little bit. So, we've got fires in Smallville. On the x-axis, we have the number of firefighters at the fire. And on the y, we have the amount of damage in cost or in money. So we can clearly see, I can draw a line of best fit here, going right through the middle. We can clearly see that as the number of firefighters increase, the amount of damage is also increasing. So we need to describe the association. That means tell me the strength, the direction, and the form. So the strength, I would say this one's going, well, you tell me, what are those three things? All right, so I would say that would be a moderate strength. The next thing, direction. It is going in a positive direction. And the last thing, is it linear? Is it nonlinear? It is linear. All right, the mayor immediately orders the fire department to send fewer firefighters to each fire so that there's less damage. Why do you think the mayor said this? Do you agree with the mayor's decision? Explain why or why not. So, hopefully you understand that if we decrease the number of firefighters, that doesn't mean that the amount of damage is going to go down. So according to our graph, it looks that way. So, do you agree with the mayor's decision then? So hopefully you say, no, do not lower the amount of firefighters. So since we're saying no, don't lower the amount of firefighters, there has to be a reason, something else that's happening in this correlation. And hopefully you realize that if the fire department is sending a smaller amount of people or fewer amount of people, then that must mean it is a smaller sized fire. And obviously if it's a smaller sized fire, the amount of damage is going to also be down. So there's our little hidden piece of information. It's the size of the fire. So hopefully that makes sense to you, that if they are sending fewer firefighters, and that is probably because there is a smaller fire, which would then obviously mean that the amount of damage is also less. So there's the reason that for the correlation. So here the correlation does not imply causation. Looking at number 2, a dietitian studying the benefits of eating spinach surveyed a large sample of individuals. She recorded the amount of spinach they ate and their physical strength. The dietitian found the spinach eaters to be much stronger than the non-spinach eaters. The next day, the newspaper headline was, "Popeye was right. Eating spinach does make you stronger." Do you agree with the newspaper? In other words, do you agree that if you eat more spinach, you will grow stronger muscles and increase your strength? All right, so once again, I'm going to say no, I do not agree. Just because I eat spinach does not mean my muscles are going to increase. So just because a person's eating spinach, that doesn't mean that the muscles will increase. You can eat as much spinach as you want, and that might be good for you, but you're not going to get stronger. So the dietitian correctly found an association, and what could explain the association other than spinach makes you stronger? And this is going to be the healthy lifestyle. If a person eats a lot of spinach, they more than likely have a healthy lifestyle, which means they're probably going to the gym, and they're maybe going for runs. They're doing other things that are making you stronger. So then my answer to letter B, if you eat a lot of spinach, then you are probably living a healthy lifestyle and gaining muscle because of that healthy lifestyle. So once again, maybe because you're going to the gym, maybe because you're going for runs, could be a whole list of things. But it's not just because you eat spinach. A person cannot eat spinach and gain a lot of muscle that way. They have to eat the spinach, they have to eat a good diet, they have to exercise, they have to do all of that, and then they will gain muscle. All right, go ahead to the next page, backside.